All right, y'all. This is the CA2 review. We're going to start with part 1, chemistry. Before we get into the review, we're going to go actually to our brain dump just to make sure that we remember what a great brain dump looks like. The first thing that we need to write down is ape man, okay? So that ape, remember, is atomic number equals protons, which equals electrons. And then the man part is how we solve for our neutrons, which is mass minus atomic number equals neutrons. Some other things that I want to point out, group versus period, right? Groups go up and down while periods go left to right. And then we write valence electrons because the group number tells us the number of valence electrons. The period number tells us the number of energy shells. I also put that on the side. I write my periods, so I remember, okay, if we're in period 4, that means that these elements have 4 energy shells. And then I write groups up top to remember group 1, 1A, 2A. That tells you the number of valence electrons. I also break down our metals. Remember, with our stair step, these elements on the stair step are our metalloids. And then to the right, we have our nonmetals. To the left, the rest of the table besides hydrogen are our metals. And one other thing is that we write our reactivity, right? So elements in group 1 are very reactive because they only need to lose 1 valence electron. And our elements in group 17 are also very reactive because they need to gain 1 valence electron to have a full outer shell. Elements in group 18 are non-reactive because they're already full, they're happy. So that is our brain dump. We're gonna move into the review, okay? So part 1 is chemistry. This is our first unit. We're gonna start with our first section, atomic structure. The first note, the actual structure of an atom, okay, is that we have a nucleus that's made of protons and neutrons, and then electrons orbit that nucleus or fly around. This chart tells us the charge, mass, and location of each of our subatomic particles. Okay, just a reminder. And then the Rutherford theory, just the theory of how the subatomic particles actually move in the atom is just that electrons orbit a dense nucleus, right? So a dense nucleus of protons and neutrons, and the electrons orbit that. Most of the atom, though, is made up, as we know, of empty space. Okay, the next part is elements identity. The element's identity, or what tells us what an element is the number of protons. So for example, if we look at the periodic table and we have our atomic number of 17, we know that means that this element has 17 protons, so it must be chlorine, okay? Beyond element's identity is element's chemical properties. So the element's chemical properties, or its reactivity, is determined by the number of valence electrons, okay, needed to fill the outer shell. For example, if you have an element with 7 valence electrons, it needs to gain 1 valence electron to have a full outer shell. Therefore, it is a very reactive element, okay, going back to our brain dump. The next piece, part D, is just a reminder that groups go up and down and periods go left to right. This is so easy to forget. So we use this visual group period to remember that groups are vertical, periods are horizontal, and the periods tell us our energy shells while the groups tell us our valence electrons. Okay, that's just an example here. We can tell that the number of valence electrons, again, the electrons on the last shell, right here we have 1, 2, 3 valence electrons, which tells us this element is in group 3. In the number of energy shells, we have 1 shell, we have 2 shells. Okay, so there's 2 energy shells, therefore this element is in period 2. If we go to group 3, okay, group 3 and period 2, we come across, and that element is boron, right? Its atomic number is 5. Therefore, it has 5 electrons. 1, 2, 3, 4, 5. Yep. On to the next page. Our next page is counting atoms. So this is something that is very mathematical, right? So just some reminders. Our subscripts, when we're counting atoms, are the small numbers. They tell you how many atoms are of that element in a molecule. Coefficients tell you how many molecules there are, and you multiply by each element, right? If there are parentheses, guys, and the element is inside the parentheses, we need to multiply by the outside subscript. So let's look at some examples. If we have this whole molecule, the number of Na sodium atoms is 2, okay? This sodium is not in the parentheses, so we don't need to multiply by anything else. There's no coefficient. Carbon is inside the parentheses, so we have to multiply its subscript 4, by the 3 on the outside. So 4 times 3, we know that there are 12 carbon atoms. Same thing with hydrogen to get 3. Our next example, we have a coefficient, so we know we're gonna have to multiply that coefficient times each element. So for carbon does not have a subscript, so we just do 2 times 1 is 2. For hydrogen does have a subscript, so we actually do multiply our coefficient 2 times that 2. Same thing with oxygen, except oxygen does not have a subscript, so we have our 2 times oxygen's 1 gives us 2 atoms. Okay, here, don't get this mixed up. If we're counting the number of atoms for oxygen, even though it has a subscript 2, don't leave out that extra O to remember that there are actually 3 oxygens here, even though they're not next to each other. Okay, lastly, for part 1, our chemical versus physical reactions. Signs of a chemical reaction are color changes, temperature changes, bubbles or fizzing, like a gas is created, a precipitate, meaning that a solid is formed from 2 liquids, or that a new substance is formed or energy is released. Okay, these are all chemical reaction signs. Our physical reaction signs are phase change or shape change. So for example, if you had a liquid that turned into a gas, that is a phase change or a physical reaction. A shape change could be like cutting hair to make it shorter or in a different shape. That is a physical reaction. Thank you guys for sticking with me for part 1. Part 2 on physics is next.